So, good morning everyone, and welcome back to our class in Mechanics of Deformable Bodies. And now, we will talk about our second lesson, which is still under our first module, which was about the overview of Mechanics of Deformable Bodies, but now, we will be talking about stress.
It really hurts ang magmahal ng ganito kung sino.
Our goal for this lesson is that we should understand first the concept of stress, and number two is to solve problems about average normal and average shear stress. But first, let us first understand what is the meaning of stress. Because probably you might think that stress means na-stress mo sa pag-study, na-stress mo sa inyong pagpanghugas. That's not the stress that we are talking about right now. Because actually, in Mechanics of Deformable Bodies, stress is defined as the intensity of an internal force acting on a specific plane or area. And it is usually defined as force over the area where the force is applied. Okay, so again, take note that it is again the intensity of a force, an internal force that is acting on a cross-sectional area. So, for example, imagine that you have this two sanga, and as you can see, ang kaning usa ka sanga kay baga, ang kaning usa ka sanga kay nipis. Now, I am going to exert a tension in these two kahoy. So, I am going to exert the same force of tension in these two sticks. Ambot nun si tawag ani sa English. Okay, so, sige. Let's say, nagbutang ko og 10 newtons aning akong stick dire. So, lisod siya, iputol kong baga siya. And if I'm going to pull this one, so naputol siya with the same amount of force. Why? It is because of the influence of the cross-sectional area of the stick. So kung dako ang cross-sectional area sa atong stick, mas gamay siya og stress. Therefore mas dugay siya maputol. But if ang cross-sectional area sa atong stick kay gamay kaayo, then mas dako ang iyang stress. Therefore, it is more likely to fail. Okay? So ingana lang. So, I guess naamoy na familiar sa unit sa stress. Because again, stress has a unit of force per area. And probably you might remember on your fluid mechanics that force over area is also the unit of pressure. So what is the difference of stress and pressure? Okay, so take note, I have na ako'y gi-stress out dito nga word, and that is actually the difference of stress and pressure. So again, let us go back to the definition of stress. It is the internal force acting through a cross-sectional area of a body. Take note for the word internal because that is actually the difference between stress and pressure. Because pressure is actually defined as the intensity of an external force that is acting to a cross-sectional area. On the other hand, when you talk about pressure, just imagine yourself, you have this finger, you are poking your finger on your hand, so your finger is exerting an external force to your arm. And unsa man ang stress dira? So, the contact between the surface of your finger that is in contact with your arm, mao na ang atong area nga atong i-consider. And the force is actually the force that you applied from your finger to your arm. Okay? So force of your finger to your arm and the area in contact of your finger to your arm. So mao na ang pressure. Kay external ang atong force. But on the other hand, when you talk about stress, it is the internal force. So For example, ako ni gibira ang akong kamot, ako ni gibira ang kani nga kuan nga pen. So, kung unsa ang tension, di ba we have learned that there is an internal force that is acting inside this pen when I am going to pull this one. So, ang atong gi-consider karon nga area kay ang cross-sectional area sa aning pen. Kay internal mga force ang naa sa aning nga pen. Wala man ta nag-exert ang external force but on the ends lang of this pen. But now we are considering the internal reactions that is happening at this point. Okay, so there are two types of stress. And again, kaning two types of stress, they only differ to the direction of the stress nga asa siya padong. So first, let us talk about normal stress. And actually, normal stress has a symbol of sigma. Okay? The small letter, sigma, dili ang capital letter, capital Greek letter, whatever. Okay. So actually, normal stress is the intensity of a force, the intensity of an internal force acting perpendicular or normal to the cross-sectional area. What does that mean? Diba, we have already reviewed of those forces. And we have learned that naatay normal force. Same gyapon na sa atong normal stress. That stress is applied perpendicular to the cross-sectional area. For example, I have this shaft. And di ba niingon ta sa una nga mao ni ang normal force. Same goes with your normal stress. It still goes on the direction normal or perpendicular to your cross-sectional area. So this is your normal stress with a symbol of sigma. To get the average normal stress of a cross-section of a shaft, all you have to do is to have this equation, normal force over cross-sectional area. So sigma is equal to N over A, where N is your normal force. Okay? And your A is your cross-sectional area. So, unsa ganini? Ang N, maoning kani nga force. Okay? Ang A, maoning area ani. Ingana lang ang atong normal stress. On the other hand, for our shear stress, it is, again, the force acting parallel to your cross-sectional area, which is again expressed in tau. And still, parehas gyapon sila og kanang formula sa atong normal stress, but ang nag-differ lang nila kay ang direction sa atong force, which is sa atong shear stress, it has a formula of V over A. Unsa maning V, sir? Nganong V og N man? Take note again, these are forces. The only difference of these forces is its direction. So, again, on your normal stress, ang atong direction sa force is perpendicular to your cross-sectional area. But on the other hand, on your shear stress, the direction of your force is parallel to your cross-sectional area. That is why we call it V. Okay? So, ato ibutang, shear force over X section area. Okay? So, ingana lang kasayo ng atong pagkuha sa atong average normal stress and average shear stress. Nakasabot. Now, take note, sa atong shear stress, it also depends on what direction it goes through. So, di ba, we have this Cartesian vector x, y, and z. So, if ang atong shear stress is going to the x-axis, we call this one tau yx. And we call this other shear stress as tau yz. Nga na ito lang gitawag yung ana. Kay, para natay difference sa ilang duha. Kay, tanawa ang direction ani. Lahi ni sila ang direction. But this subscript y, mo ni siya ang axis perpendicular to your cross-sectional area. So again, this is your cross-sectional area. So your first subscript should be the axis perpendicular to your cross-sectional area. And your second subscript, which is ang imong subscript there is x. So mao na ang direction sa imong shear stress. So x dire kay x man ang atong direction sa atong shear stress. Pero z dire kay z ni siya kay z ang atong direction sa atong shear stress. So, now, let me draw something. Nag-draw ko og body na pod. And again, this body is subjected to forces. What di lang tawag pangan, probably F1, F2, F3, F4. Sige. Now, again, ako siya gi section at this portion. Kani nga body. So therefore, again, na-expose ang mga forces ani nga body. Now, let us take one element dira sa atong body. After we have taken this small element, ato ni siya gipadako, okay? So, generally, if a cubic element in this body is subjected to stress, generally daw, ang kaninga cube, ma-experience siya og normal stress on all of its sides. Diri pod sa likod, and diri sa ubos, and diri sa likod. Okay. Each of the faces of this cube is experiencing normal stress, and each faces of this cube is also experiencing shear stress. So, na-shear dira, na-shear dira. Don't mind the direction lang sa ha. Ato lang sa nag-assume nga yung ana. Pero, all of those faces in this cube naka-experience og usa ka normal stress sa kada face and a pair of shear stresses going perpendicular with each other on each face as well. Okay, so mo ang atong general state of stress, which is generally when a body is subjected to external force, the stresses nga nahitabo diha sa every cubic element sa imong body naka-experience ani nga mga stresses. Okay? So take note about that, and that is just a general information as well. So now, what are our units in stress? I have already mentioned this one earlier, but let's go back to its units. So unsa units sa stress? Again, atong stress is force over area. In metric system or SI unit, ang unit sa atong stress, di ba? Atong stress, ato lang ingon nga normal stress, is equal to force over area. And ang unit sa atong force is newtons. Normal niya, newtons. Newtons over meter squared. Okay? And unsa man ni siya? Kani siya is actually Pascal. So 1 Newton per meter squared is actually 1 Pascal. Okay? So take note about that. Pascal. Now, in English unit, our formula of stress is again force over area. So, its unit in force is pounds. Diba? Ang atong area is in inches squared. So, unsa man ni siya? Sa shortcut, kung ang n over m squared kay Pascal, unsa man yung shortcut sa LB over IN. That is actually PSI, or pounds per square inch. Mana? Pounds per square inch. Or, kung 1,000 PSI na ni siya, ang iyang pangalan kay 1 KSI. So, po rin KSI? Kilopound per square inch. Ganun lang. Okay? So, PSI, pounds per square inch. KSI, 1,000 pounds per square inch. Okay? So, ingana lang atong units sa, and sayon lang kayo, no? Sayon lang ni siya kaayo for now because we are talking about average stresses. If you're going to determine the maximum average normal stress, when you say maximum, mao na ang pinakadako nga stress nga naa sa imong bar. Okay? Kano sa man na siya ma-apply? For example, your bar has different cross-sectional areas. Diba? Nakahibaw man ta. Parehas equal man niya ang atong force dere. And kibaw man ta nga gamay ra ni siya og stress dere. Magtikadako yang stress dere and at a very small area mas dako ang iyang stress. With the equation again n over a. So since denominator man atong a, the bigger the cross-sectional area, the smaller the stress. But the smaller the cross-sectional area, the bigger the stress. So we will all know that the maximum normal stress in this kind of beam is located at this portion. Okay? In this case. Another example of determining the maximum normal stress of a beam, let's have this beam given nga constant ang iyang cross-sectional area throughout, pero naay change of loading diri. Nya, change of loading dira. Nya. Ana. So in this case, ato kitaon ang behavior sa normal force sa kada segment ani. Nga ato buhaton adto mag-graph. So assuming siguro nga ang left nga direction mao na ang positive. So saka siya nya right man siya ninaog siya and then minaog siya and then mibalik og 0. So dapat and then ato i-locate as sa ang maximum normal stress dira. So in this case siguro I guess na diri kay mao man siya ang pinakadakog value. We will have an example of that one later on for you to understand it further. Okay. For example, we have this bar which has a constant width of 35 millimeters and a thickness of 10 millimeters. So natay bar, ang iyang width is 35 millimeters and thickness of 10 millimeters. So we have to determine now the maximum average normal stress in the bar when subjected to this kind of loading. So as you can see, every part of this bar is naay mga changes of loading. So mao na giingon kaganiha. So what we have to do is to determine the maximum average normal stress. So ato i-draw ang bar. Draw na to ang bar. And then sa end niya na siya 22 kilonewtons. On the other end na siya 12 kilonewtons. Okay? And at point B na siya gi-exert nga aton lang i-plus ang duha kay its distance doesn't matter man. 18 kilonewtons. And then at point C kuha na pud siya 8 kilonewtons. So ato himuan siya og graph. Ato siya graph. So point A, point B, point C, point D. Anya, mao ni atong zero line. 0. Okay. So assuming mag-assume ta nga ang atong direction sa left is mao na atong positive. So, kung mo ato siya left, musaka siya. So, in this portion, ni ato siya left by 12 kilonewtons, so nisaka siya og 12 kilonewtons. Dere, wa man siya loading dere, so constant na siya nga 12 kilonewtons. And makakita mo nga pa-left gihapon ang atong 18 kilonewtons, so nisaka na po na siya. 12 plus 18, 30 kilonewtons. So nisaka siya 30 kilonewtons, so wala naman po loading dere. So constant na po ng iyang load, ang iyang kuan dira load. And karon padung na siya right. So minaog siya og 8 kilonewtons. So 30 minus 8 is 22. So himo siyang 22 kilonewtons. And wa na po siya loading dire. So constant na po na. And then kita na po nga padung na po siya sa right ang atong 22 kilonewtons. So ninaog na po siya. And then may balik og 0. So this is our loading behavior sa atong beam nga kani. And then karon asa man nato makita ng maximum normal stress? Kung asa dapit ang maximum normal nga load nga ang atong maximum internal nga normal force. Asa man dapit ang atong maximum internal normal force? Kaning atong 30 kilonewtons, obviously. Kay mao man pinakadako nga value. So, pangitaon nimo pinakadako nga value dira mao na ang maximum. So, ang atong maximum nga internal force Nmax is therefore 30 kilonewtons. Okay? And how can you get the maximum normal stress? Using this maximum normal force, internal normal force, to get the maximum normal stress, all you have to do is to input Nmax over the cross-sectional area. Ang atong maximum normal force, 30 kilonewtons divided by your cross-sectional area. Since this one is made of a rectangular kind of bar, yung cross-section sa atong bar is rectangular, so kibaw na ta, 35 millimeters times 10 millimeters. Okay, ato itanong cross-section ani, mao ni ang cross-section sa atong bar. Mao ni 35 millimeters and mao ni 10 millimeters. So, all you have to do is to calculate this one. Sayon ra kaayo. Okay, so the answer here is 0.085714 kilonewton per millimeter squared. Humana ba ta? Ato pa na-simplify. Ano man? Okay? Millimeter man siya. So, take note ani ha. Kung makakita kag newton per millimeter squared, ang tawag ana niya is megapascal. Take note. Kung newton per millimeter squared, megapascal na siya. So, unsa man nato pag imong newton per millimeter squared? Ato ni multiply by 1,000. So, atong buhaton is 0.085714 times 1,000. Magkalakyo gihapon ko pastilan. So, 85.714 megapascal. So, this is your answer. Always take note of this conversion because this is very important. Kung newton per meter squared niya, this is pascal. If kilonewton per meter squared, this is kilopascal. But if newton per millimeter squared, this is called megapascal. Take note. Okay? So, this is your maximum, average, maximum, internal, normal, stress. Nga nakatas atong pangana ni. Okay? Understand? Understood? We have another example. Magkaya ba nila itong edit? We have this cylinder which is made of steel. having a specific weight, specific weight of 490 pounds per cubic feet. Now we have to determine the average compressive stress acting at points A and B. So we have these elements A and B at the bottom of this cylinder. And what we are going to do is to determine the average compressive stress acting on those elements. Okay? So what are we going to do with that? So first is to draw the free body diagram. And then, kibaw man ta nga naa diri si A and naa diri si B. And kibaw ta nga kani si A ug si B ila gipas-an ang tibuok nga ang kaning cylinder from the top to 0.75 feet from the bottom. Okay? So, ang atong pangitaon ani is ang weight from this point up to this point, which has a height of 2.75 feet. Okay. So, unsa man nato pagguha sa weight ani nga portion sa cylinder? Saan nato pagkuha? So, ato pangitaon una is ang weight aning atong cylinder. So, to get the weight of the cylinder, what we're going to do, ang gihatag nato diri kay ang specific weight, which is gamma ST is equal to 490 pounds per cubic feet. So, by seeing its units, ang atong goal kay makuha ni nato. Unsay dapat nato pangitaon para matangtang ni siya o mabili na lang ni siya? Mangita taog volume. And then, asa man nga volume? Mao na ang volume aning atong cylinder. So when we get the volume, and by using this specific weight, we multiply the volume of this cylinder, we will actually get the weight of the whole cylinder. Okay? So, to get the weight of the whole cylinder, gamma ST times the volume of ST. So, 490 pounds per cubic feet multiplied by what is the volume of a cylinder. Ang volume kay area times height. So, unsa may area ani nga circle? Pi times radius of, given there is 0.75 feet squared times height of 2.75 feet. Sugot mo nga yung grade, 2.75. Sugot. We will get that the weight of this whole cylinder is actually equal to 2,381 pounds. Ano ang weight sa cylinder? Okay? So, to get the normal force nga gipas-an aning atong A ug B, ang atong buhaton is to get the force nga naa diri nga kuan. And that is actually using the equilibrium equation, summation of forces along, sige, y na lang ni. Along the y, going up is positive, which is equal to, sa ito itawag diri nga portion, n. Sige, ito itawag n. N minus w is equal to 0. So, your n is just basically equal to 2,381 pounds as well. So, di ba? Okay, this is in equilibrium. And then, ang atong gisolve kaganiha kay ang weight sa aning atong cylinder. Di ba? Naa pa man ni siya sobra dire, pero ato na ni gi-discard kay diri man ta nagtan-aw sa A o B na portion, which is sulod siya sa atong cylinder. And naa siya sa babaw 0.75 from the ground. Okay? So, we have it here, and we should get the normal force. And to get the normal stress internally in this section, we have to apply the average normal stress equation, which is average normal stress is equal to normal force over cross-sectional area. Sige, diha sa tasa A. So, unsa may normal force sa A? 2381 pounds per cross-sectional area, which is pi times 0.75 squared. And we have the answer of 1,347.5 pound per feet squared. Wala itong answer. So, if we want to convert it into PSI, then all we have to do is to, wala tayo space, oy. A is equal to 1,347.5 pound per feet squared times 12 inches and 1 feet, so square. And we will get the answer of 9.36 pounds per square inch. And that is the answer for sigma A. How about sigma B? Sigma A and sigma B is actually on the same cross-section. So, equal lang sila. They have the same stress because they are on the same section. Okay? Because we are just talking about average normal stress. And either way, kung asa na siya no-locate on the same section, kung same ang ilang section, ang kanang section ang kanang atong gikat, then they have the same values. Unless kung sa ubos nga section, so lahi na jud na sila value kung lain nga section. Diba? Understood? Have you understood our example? Okay. So, wala pa tanahuman, kay average normal stress pa to, and now we will talk about average shear stress. So, di ba, you have remembered that shear stress are those forces and those stresses that act parallel to the cross-sectional area. So, when can that be possible? Say, for example, you have this bricks, these blocks. And when we are talking about shear stress, I have these 2 blocks below, and I have this 1 block above. And I am going to put a force on this 1 block above. So, they say that this block above is experiencing shear stress. How? How is this experiencing shear stress? So let us check it on the drawing. So say for example, again, I have it this way. Okay? So I am putting a force at this portion. Now, equilibrium equation says that for this one to be in equilibrium, these 2 blocks should also be producing a force going to this block above. And let's say the force that we have applied in this block is called P. So therefore, for this one to be in equilibrium, gitunga, ato i-assume nga nastunga na siya gibutang. So, gitunga sa kaning atong ubos ang force of P. So let's call it P over 2 and P over 2. Okay? So this is morning reactions nga nahitabo aning atong block. And this block here is experiencing a shear stress. Why? Nag-experience siya og shear stress at these sections there. So, ito natanahon ang kanang section. So muna niya itong block. And then, at this portion, to ikat dira na expose ang atong shear stress diri sa atong block. So naa ni siya shear stress diri kay gi-push man ni sa atong ubos diri. So naay shear stress ang atong block at this portion. Nganuman kay ang force nga nag-exert aning atong block is going parallel to this cross-sectional area. Okay? Kay diri man na-exert ang shear. Now, how can you get the average shear stress of this block? All you have to do is to use the equation tau is equal to shear force over A. And in this case, we are using P over 2 as shear force nga naa diri. So, let's consider your shear force as P over 2 over your cross-sectional area, which is this one. Okay? Take note nga nung P over 2 kay kani man atong gi-consider. Kung kani pud atong gi-consider, P over 2 pud na siya. Kay nga nung P over 2 kay gitunga nila ang load sa atong P to be in equilibrium. Okay? Assuming again that ang imong P kay naa sa tunga sa imong block. Okay? So P over 2 over A. Kalimut po. The average. And also, take note that this equation is an approximation. This is actually not the real situation nga nahitabo sa imong bar. And later on, we will discuss that one deeper when we are talking about transverse shear. Okay? So, now, let's talk about shear stress equilibrium. We have this block. Actually, this is already in your modules, but let us discuss this one. And this block is subjected to a shear force of V. And now, let's take a small element, cubic element in this, at the top portion. Okay? And ato gi-zoom ang atong cubic element. Now, naay shear force, naay shear stress nga nahitabo at this section, di ba? And let's call it as tau zy. May gitawag dito sa module. Tau zy ang tawag sa atong shear stress diri. Pero this block did not deform. Okay? Wala pa siya niabot sa point nga ni-deform siya. So this is still in equilibrium. So kung moingon tag equilibrium ni siya, dapat naay untay mo equate sa iya para mo zero ang iyang sum, di ba? So unsaon man siya pag zero sa iyang sum? Especially sa atong summation of forces and summation of moments. Summation of moments. So dapat both of them should be equal to 0 if we are talking about equilibrium. So kanus aman ni siya ma-equal to 0. If naapod tayo the same magnitude of shear force is also acting to this small element. And where could it be possibly located? Diri sa bottom nga face sa atong cube. Nata dira tau prime zy. Kaning tau prime zy parehas siyang magnitude sa tau zy but is acting on the opposite direction. Okay? And we also have to sum our moments to 0, kung saan man yung mahitabuan dapat man ang atong moment equal man to 0. And then kung mag-moment ta at this axis, okay, mag-moment ta at this axis. So, mo 0 ba ni siya kung ingani lang nga case? Sige, ato da ikuan. Summation of moments at point at x sige kay x-axis man ni. Y-axis ni, z-axis ni. Summation of moment at x. Natay force dere, which is tau, ay stress dahil na siya, tau zy times ang area. Let's assume that the area of this cube is delta x, delta y, and delta z. So since this is your force, this is your stress, and this is your area, so stress times delta x times delta y. Okay, so mao ni imong force, and your moment arm should be this one, delta z. Okay? Equal ba siyang 0? In this case, dili pa. Okay? Napatay kuwang. Kay kani nga force, dili, it will create zero moment man. Okay? It is collinear. It will muigo siya sa atong axis of moment, which is ang x-axis. So, dapat, para ma-zero siya, dapat na siya pares nga opposite pog direction. And that will actually be on this face of your cube. In this case, ang isa dapat padong sa babaw. Kay kung padong ni siya sa babaw, ang mahitabo, positive pa nga na, ang mahitabo, i-minus na siya, and then, tau yz times ang area of delta x, delta z, and then ang moment arm of delta y. And in this case, mo zero na jud ni siya. Kay equal man ni silang magnitude o parihara man ni silang mga lengths. So mo, zero na ang atong moment. And para ma-equate po ni siya, ma-equilibrium po ni siya sa atong force, dapat na po ni siya partner. It should be located on the other side of the element and it should be going down. So atong tawag ani is tau yz, tau prime yz, and this is your tau yz. So ingana lang siya. So therefore, this kind of equilibrium sa atong shear stress is actually what you call the complementary property of shear. So complementary property of shear says that all shear stresses must have, all of these four shear stresses must have equal magnitude, and it should be directed either towards or away from each other. Okay? At opposite edges of this element. So, to satisfy equilibrium di, dapat again, the directions of our shear stresses, the directions of the adjacent shear stresses should be directed towards each other. So, kani silang duha towards each other ni sila padong. And, kani adjacent man pud ni sila nga faces, so, away from each other. So, wala sila nagduol, palayo sila sa usag-usahon. Pero on this side na pod, towards na pod sila. So, that is actually the complementary property of shear. And if you have this kind of kuan, kaning setup, you can say that your element is in equilibrium. So, ganun lang. Gamay lang siya nga chismis, pero yeah, libog siya, no? Libog siya gamay, pero this is just some concepts that you have to take note of. And take note again, all of these shear stresses have the same magnitude. So, they are all equal. So, for our first example, we have this beam. And kaning nga beam, at the left end of this beam is gisuportaan ni siya og 20 mm diameter nga beam, nga pin. And on the other end, supportan ni siya og cable, and at the end of ang nag-contact sa cable og sa imong beam is a pin gihapon, which is 30 millimeters. So what is the shear stress in each of those pins? Sige, let's try to answer this one. So,
Again, ang atong buhaton, mag-draw ta sa beam. Kani, nag-support ani niya. No. Nag-draw ta free body. Karon ato ipakita ang mga external forces. So since on your point A, this is supported on a pin. So ang nag-restrict ani is ang X and Y. So AX, AY, and AX. Diri sa atong B, nag-support niya kay cable man. So ang iyang force is going there and at a slope of 3, 4, and 5. Napatay kuwang. Wala pa nato nabutang ang force of 30 kilonewtons. So, saan man ito pag-solve? We should first determine all these unknown forces. Okay, so how can we determine these unknown forces? FC. Okay? Saman. Sa may una nato baton. Diba? Ang atong goal kay makabilin ta og one unknown. Para makabilin ta og one unknown, all we have to do is to moment at this point, at point A. So, ato baton, summation of moments at point A. Para mabilin kay kaning FC. So, ato ikuan. Atong direction nga positive is going there lang sa. Okay. So, kibaw man ta, nga lisod man ni siya ikuan kay mangita pa ta sa perpendicular distance. So, ato baton, ato siya pangitaan in its components. Okay. So, summation of moments at point A, ato sa unang unknown. So, vertical, pilang magnitude sa atong vertical, ay sa atong y component sa FC. Sa ito na ito pag-solve, 4 over 5 times FC. Diba? So, positive na siya kay going counterclockwise. And then, we have, how about this one? Sa atong x. Wala nilabot atong x kay coincide naman siya sa atong point of moment. So, 0 ang atong x. Di na nato i-appeal. Naman tayo 30. And then, this one will create a clockwise direction. Ang moment arm ani niya is 6 meters. And then, minus ta, 30 kilonewtons times the moment arm, which is 2 meters. And this is equal to 0. So, we will know that FCDI is equal to 12.5 kilonewtons. FC lang, gitawag diri ha, pero sa module lahi ang tawagan niya. Okay, so nakita na nato siya. Wala pa tanahuman kay ato pa po ni pangitaon. Unsa man nato pagpangita? Sayo na lang, mag-summation of forces na lang ta. So, summation of forces along the x ta, assuming positive is going that way, equals to AX. Napatay lang nga mga x components. Apa? Kani si Ja, di ba? Plus 3/5 of FC. Pilang FC? 12.5 equals to 0. So, our answer sa atong AX is equal to negative 7.5 kilonewtons because it's going that way, pero ang sakto ding assumption should be 7.5 kilonewtons going to the left. Okay? So, nanata. Summation of forces of y na punta. Summation of forces of y going up is equal to AY plus 4/5 of 12.5 kilonewtons equals to 0. So, therefore, our AY, again, ang answer ani nga AY is negative. So, therefore, dapat ang answer sa AY should be 20 kilonewtons. And since negative man siya kung going up, so ato positive going down. Mo ni answers pero wa pa tanahuman kay di man ni mao atong gipangita. Ang atong gipangita kay ang shear stresses man at the pins at point A and point B. So, ato unahon ang point A. Ato susihon, ato tan-awon ang pin sa point A. So actually, ang pin sa point A mao ni ang hitabo. Mao ni ang naka-embed sa wall. Okay, mao ning wall. Mao ni ang atong chuchu and then mao ni ang atong beam. Okay? Mao na ang atong beam. And then kana sila naka-connect na sila ang atong chuchu ug kani atong beam through a pin. Okay? So therefore, when we are going to make a free body diagram sa atong pin, ito lang ibilin ang pin, and then ang forces di ay nga nag-react dira sa atong pin should be kaning tulo. Nya unsa man to nga direction. Hindi sa ta mag-mind sa direction pero mao nang reaction sa atong pin. Okay? Kung ato na tan-awon side view, kaning atong pin naa ni siya component of 7.5 kilonewtons to the left, naa pod siya component of 20 kilonewtons downwards. Okay? So, therefore, ang resultant na ana siya dira nga dapit. Diya. So, man nato pagkuha sa stress aning atong pin. Kani nga stress. Bali day ni siya. Paing ana day na siya kay compressive. Okay. So kani siya mao ni kani siya. Okay? Kay mao ni siya. Namatay x and y component so ato sa pangitaon ng resultant para makita nato ang value ana. So unsa gani ito pagkuha resultant? Magamit ta og Pythagorean theorem. So, let's say P, ato lang tawagon ni P ha, is equal to square root of 20 squared plus 7.5 squared. So, we have your stress of the value of 21.36 kilonewtons. So, since ang kanina nga value, 21.36 kilonewtons. And that is actually the value of this one, 21.36 kilonewtons. So since ato magi-assume nga na siya sa tunga nag-igo, so therefore, ang kaning nasa isig kakilid, which is kani, mauning nagkuhan sa tong chucho, divide by 2. Okay? So, pila man ang shear? Shear force is equal to 21.30 kay V man ni sila, V. 21.36 divided by 2 is equal to 10.68 kilonewtons. So, mo ni atong shear force sa kaning tagsaan nila. Okay? Kilonewtons. And now, finally, to get our shear stress, ang atong buhaton is V over cross-sectional area. Ang atong V, nakibaw na ta nga 10.68 kilonewtons. And then, ang atong cross-sectional area, ang cross-sectional area sa pin. Ang pin is circular ang cross-section. So, to get the area of a circle, pi r squared. But ang given diri is diameter man. So, mas comfortable man kung radius to divide by 2. Pi times 10 millimeters squared. So the answer here is, you can convert this one into meters para di mo maglisod. Okay? And you can get the final answer is 34 megapascals. Okay? So again, para di mo maglisod, pwede na i-swat 10.68 kilonewtons divided by pi times 0.01 meters squared. Then, maka-answer ka anig kilonewton per meter squared. And, yeah, it will arrive on the same answer. But we're not done yet. Why? Because we still have the pin at point B. Ito tanaw ng pin at point B. Pin at point B is made of cable and then, so, ito tanawon siya sa babaw. Mo ni ang atong beam. Mo ni atong beam. And then, mo ni ang atong cable. Na atong cable. And, kana sila duha, naka-connect og pin. So, unsa may nitabo diri? Ato tanaw ng free body diagram sa atong pin. Makita nato nga ang usa nagbira siya sa cable, ang usa nagbira siya sa pin ay sa beam. Okay? Kana sayon lang na siya kay wa natay divide kay to achieve equilibrium equation dapat equal ang magnitude sa ana. Kani diri sa atong first dapat mag-equal siya by dividing this one by 2. Mao ni ang atong FB. Ay, no. Mao ni ang atong FC ba to? FB, FC. FC. And let's call this one your V. So, to achieve equilibrium equations, FC should be equal to V. Again, para equilibrium siya. Okay? So, diretso na. Wala, dili na ka mag-x ug y. Kaya kung mag-x ug y pa ka, maglibog pa ka, kaya naapatoy angle-angle. Para diretso na lang equals. Because actually, they have the same magnitude, Jud. Now, so, the value of your FC is again 12.5 kilonewtons. Nandis akong giswat kagini ha. Ako na lang na-erase. So, therefore, your value of V as well is 12.5. And to get for your shear stress at point B, at the B part of your pin, all you have to do is to tau B is equal to V over A. So, you have given the V is 12.5 kilonewtons over the cross-sectional area of pila na po diameter atong kuan element. Diameter sa atong element is 30 millimeters ang sa P ay sa B nga pin. Okay? So, kakapoy naman ko pi r squared. So 30 man ang diameter ato hatag diri kay ang radius, so 0.015 meters squared. And our answer, so answer diri kay 17,683.88 man siguro na kilonewton per meter squared. So unsa man ni siya? Kilonewton pa man ni, so ato pa ni multiply 1,000 moabot na ning 17 million. And we all know that 17 million is 17.683 megapascal. Okay? So, these are the answers of the problem. Well, taas siya. Pero, yes, this is strength of materials, so expect for long problems. Okay? So, number 1 pa to. Napatay number 2. Oh my goodness. Okay, so another problem, number 2. So we have this inclined member which is subjected to a compressive force of 600. So naka-inclined member, na force of 600 pounds. And then we have to determine the average compressive stress along the smooth areas of contact at AB and BC, part of that contact. Okay, and also find the average shear stress along with the horizontal plane, dB. So how are you going to solve this problem? Okay, let's solve this one. So, ang atong gipangita kay ang average compressive or normal stress nga naa dira sa atong plane AB. Plane na siya A and B. And sa atong plane BC. Okay? Ato gipangita ang compressive stress or that is normal stress. And we are also finding for the average shear stress at plane DB. Okay, so how are we going to do that? So this is a combination of normal stress and shear stresses. So I chose this example kay para naatay lisod nga example. Okay, so how are you going to do this one? First is to draw the free body diagram. So, asa man nato i-draw nga free body diagram? Diri sa atong inclined member. So, your inclined member, ang iyang angle is 3, 4, 5. Okay? Mo na yung angle sa atong member. And then, ay 600 pound nga force gi-applied. Ha? Gi-apply sa atong inclined member. So, naay reactions diri og diri. So, let's call this one FBC and FAB. So, how can we solve this? How can we determine these unknown forces? Simply by using the summation of forces. So, ato unahon ang FAB, summation of force along the x, assuming positive. So, FAB minus ang angle 3/5. 3/5 times 600 pounds equals to 0. So, our answer for that unknown FAB is 360 pounds ang atong FAB. Okay? Easy breezy. Next, for our FBC, to gamiton summation of forces along the y going up. FBC minus 4/5 of 600 pounds. So, ang atong answer sa FBC is 480 pounds. Okay? So, mo na siya ang nahitabo dira. And also know, through the concept of equilibrium, nga ang kanang contact point dira sa atong inclined surface and diri sa atong kuan, nag-create po na siya og compressive force diri sa ani nga surfaces. Ani nga surface and diri nga surface. And by equilibrium equation, we all know that this one has the same force of AB and this one has the same force of BC. So, diretso na nato butang. Ang AB is 360 pounds and ang BC is 480 pounds. So, yun lang. And ang atong normal stress, ang area nga naigo niya dira. So, this is your force and this is your area nga imong giigo dira. And on this portion of pod FBC, this is your force and this is your area. And for your shear stress, this should be your force and this is your area. Ito na siya tagsa-tagsaon. So, ato unahon pagpangita ang normal stress ani nga portion. Unsa man ato pagpangita? Normal stress of unsa man na siya? Of AB. So, average normal stress of AB is equal to atong force again, we already knew normal force over cross-sectional area. 360 pounds over cross-sectional area of 1 inch times 1.5 inch. So 360 divided by 1.5. 240 pounds per square inch, or this is 240 psi. So this is your answer on stress at AB. Easy breezy, di ba? So your average stress at BC, so this is your force BC, and your area should be perpendicular to your force. So, mo na itong force. And again, atong force is 480 pounds divided by ang area dira, 1.5 and 2. So 2 times 1.5. So, pila man na? This is 160 pounds per square inch, so PSI. So this is your answer for the stress at BC. And finally, your shear stress at DB. So, kaninga stress, this is your area, and the force should be parallel to that area, which is this one. So, imong gamiton kay ang shear stress of DB is equal to 360 pounds divided by the area of 3 inches times 1.5 inches. So, calcio 80 psi. So, these are your answers for this problem. So, again, I hope nga nakasabot mo sa pagkuha sa direction sa force. Maka-identify na mo as a normal stress o shear stress. Again, the most important nga dapat ninyo i-take note is ang normal stress, it should be your force acting perpendicular to your cross-sectional area, and for your shear stress, it should be the force acting parallel to your shear stress. Okay? So, let's have a brief summary sa atong gi-discuss karon. Ay, wapatan ako man. When you are designing buildings, this is so very important to take note when sa imo pag-approximate sa mga dimensions sa imong mga structural members. And to ensure the safety of structural members, it is necessary to restrict the applied load to one that is less than the load that member can fully support. So dapat, sabot lang ani, dapat magbutang ka og allowance sa kanus amo fail ang imong structure og sa unsay tanan possible nga imong gi-apply nga load ana nga structure. Okay? Kaya nga dapat man ta magbuhat ana unsay mga rason. First is the intended measurements of a structure may not be exact due to errors of fabrication or in its assembly of the component parts. So probably siguro kay naay mga kanang imperfections, so you should consider those things. There are also unknown vibrations or impacts or accidental loadings that may occur and wala nimo na apil sa pag-account sa imong pag-design. So, murag consider all those probably kanang mga lakaw-lakaw sa mga tao, basin wala na nimo gi-apil sa consideration, and all those probably earthquakes or bagyo. So, dapat diha na nimo ibutang saan ang allowance. Number 3, probably there are atmospheric corrosions, decay, or weathering that will cause the material to deteriorate. So, basin kadugayan kaya ang imong mga materials magkaraan, magtika dugay na. So, therefore, magtika guba and making it butangan mo allowance sa imong pagkuan sa sa dimension sa imong beams probably can save you. And number 4, some materials such as wood, concrete, or fiber reinforced composites can show high variability in mechanical properties. So, ang kanatong mga wood, lahi-lahi na silang mga mechanical properties na usahay dili magkapareha sa uban nga mga species of wood. So, you should consider those things. And kanang akong gisulti nga allowance man atong gitawag nga factor of safety. So, you should have a factor of safety nga imong kuan, nga imong i-apply ana para nakay allowance sa imong mga pag-design. Factor of safety is actually the ratio of the failure load over the allowable load. So, simply, Fs is equal to the force nga kanus amo fail ang imong material over the force nga imo i-allow nga mag-load sa imong material. So, dapat mas nasa babaw ang atong pag-fail and then nasa ubos ang atong allow. Okay? Kay mas dako man ni og value ang force sa imong pag-fail kaysa imong pag-allow. So, therefore, ang imong factor of safety, dapat it should be more than 1. Okay? It should be higher than 1 always. If imo ipaubos, wala ka nagbutang factor of safety, ana, imong gibutang kay factor of danger. Factor of danger ang imong gibutang. So, dili safety. Okay? So, umuo lang to. So, this can also be, pwede po na nimo i-apply sa stresses and sa atong normal and stress. Ay, normal and shear stresses. Pwede nimo ihimong kana or given nga ang cross-sectional area are the same. So, equal mag cross-sectional area, so makancel lang na sila. So, you can still apply this formula. Okay? So, mo to itong factor of safety and then, so, we have an example that is on your modules. Ikapuhin na kong solve. You have this example and the solution of this example can be seen on your modules. Okay, so as a summary of our lesson for today, we have first talked about stresses, and we identified 2 kinds of stresses, which are the normal stress and the shear stress. And you already knew what is the difference of normal and shear stress, I hope. And we have also tackled a bit of factor of safety. And yeah, I hope you have learned something for today. What is your favorite part of the lesson? I like that too. If you have some questions, please leave it in the comments section on the post that I will be posting later. And please don't hesitate to ask questions if you have some things that you don't understand. Okay? So, thank you for your time. Thank you for listening. And see you on the next week. Bye.